Hey y'all, it's Dr. Know-It-All. I am on my way to Lake Nona, Florida to see Glenn Cook and also Scott Walter. We are going to tour Lake Nona, which is a very technologically futuristic city. I haven't had a chance to tour it myself. And we're also going to hopefully see a SpaceX launch this evening. So anyway, what I want to talk about today, and this is my second attempt at this because I tried to use a new set of microphones and it failed miserably, so I'm going to have to test that out a little bit more. But what I want to talk today about is comprehension and understanding of the world and whether full self-driving might be doing that as well as large language models. I'm going to touch on recent discussions between Stephen Wolfram and Lex Friedman, I'm just thinking through all these things, and Ilya Sutskever, and also the interviewer with him. I will put the links to all the originals in the description if you're interested. This is going to be probably a little bit rambly. From the first time around, it was definitely rambly. Also very, very geeky, so if you're not interested in that stuff, just skip ahead and watch the next one. You can watch the cool Lake Nona stuff. So anyway, what I want to talk about, though, is the kind of steps here. And I'm going to start with Ilya in his discussion. And just a quick note about his background. This guy he is absolutely instrumental. In fact, Elon Musk himself said that OpenAI would not have been successful if it weren't for him. So they worked very, very hard to get him on board in the early days, and he has been absolutely instrumental. And even before that, he was, according to Jeff Hinton, the one of the primary drivers, if not the primary driver, for AlexNet, which was the 2012 first deep neural network that actually blew everybody away, and 11 years ago started this incredible rush towards getting AI machine learning up to the stage where it is now. So he's an incredible light in this world. And so, don't take my word for this stuff. I'm just, I'm just a nobody. I'm just me driving along, having my car drive me, which is just incredible anyway. But he basically has the idea that compression means understanding. And then I want to link that thought to Stephen Wolfram's statement that human beings and also computers are computationally limited entities in a computationally intractable universe. And what in the world does all that stuff mean? So let's start with Stephen Wolfram's idea. And that is that you have this entire universe around us right now. We have this incredible world, linguistically, physically, all of that kind of stuff. These things are just amazing, and they're incredibly intractable. They don't have quite infinite possibilities, but they have so close to infinite that there's no way that the limited computational, intelligence of our brains or computers, or frankly anything short of the size of the universe itself, would be able to computationally understand the entire universe. Just take the very simple example of molecules of air. Just imagine them as billiard balls in this cabin here around me. There are trillions upon trillions upon trillions of these molecules bouncing around in the air. To try to model out where every single one of those things was and what it was doing and how it was interacting at any amount of time forward, right? Even for 1 second would probably take a computer. I don't have this in front of me, but it would probably take a computer on the order of the age of the universe to calculate 1 second for all of the air molecules in this cabin, and that's just in this cabin in this car, right? So it's just a nothing burger to try to figure out how to make this all tractable. So what do we as humans do? Well, even before mathematics and stuff, we obviously have kind of an innate ability to model the universe. We are able to interact, we're able to walk, we're able to jump around, we're able to hunt, all of that kind of stuff. We're able to communicate with each other. So that means that we have to build a very sophisticated model of the universe in our brains in order to operate within that universe. And when you add computers on top of that, when you add computation on top of that in the sense of formulas, and computers can do that kind of stuff, you can boil a lot of things down to very simple math, relatively speaking. For example, F equals ma, force equals mass times acceleration. That's not an adequate description of the universe down to the tiniest details, but it has an incredible predictive power, including the ability to use formulas like this to get you into space, to get you into orbit and predict proper orbits and things like that. So even though it's an incredible reduction of the reality around us, it compresses that into a model that has amazing predictive power. So we have compression and we have prediction. Those are two massively important aspects here. Then if we turn to Ilya and his discussion, what he talks about is that in order for a large language model, which is the thing that he's working on, obviously, with ChatGPT, GPT-3, 4, 5, that what has to happen is that goes across trillions of words that are in the training database. And I'm going to call them words. If you want to be specific, they're actually tokens. Tokens make up words. So a word like walking would be walk plus ing. That's 2 tokens for part of that word. But anyway, it doesn't matter for the point of this conversation, and words is just easier to conceptualize. So anyway, it has access to trillions of words, and the way it trains itself, it does this unsupervised training as a base layer, and this is the part that costs tens of millions of dollars to do, because you have to throw a whole bunch of possible sentences, paragraphs, multiple paragraphs, because the window gets bigger and bigger at this thing. And what you do is you mask out different parts of it. You mask out the future, you mask out pieces in between, and it has to go in and it has to say, oh, what would I put here? And then at the beginning, it's going to be wrong always. And so it trains until it gets to very, very close to predicting the next word or the next batch of words that's coming after the things that it's already seen. And that is a form of compression, because what you're doing is taking trillions of words, which requires probably terabytes of storage. I don't have a perfect figure for that, but you're compressing that into gigabytes of storage. So you're doing at least a 1,000 to 1 compression ratio on that order, something like that. It could be substantially more than that, but anyway, that is a compression. That is taking this very intractably gigantic group of words that you've got access to in certain orders and all of that stuff, using transformers, going through, predicting what the next words are going to be, and coming up with a model of language from that. And of course, there's also English, Russian, Chinese, French, Japanese, etc., etc. So, but again, just even abstracting that away, just assuming that there was one human language, in order to do that, you have to create a model of language. And in order to do that, you kind of have to create a model of humans, because not only is it creating a model of language, but it's creating a model of language and words that come after each other that are pleasing to humans. So that's a step that was kind of the genius part of OpenAI. They did this generative pre-trained transformer thing, GPT, and they did all this training and everything, and then what they did was they put another layer on top of that, which is reinforcement learning through human feedback, or RLHF. And that is something that what they did was they said, here is this model that can generate next words, but it's not satisfying to the user because it's just generating its own thing. It's just going like, I'm just talking, I'm doing whatever, kind of like what I'm doing right now. So it was not necessarily aligned with what, in fact, it wasn't aligned with what humans wanted. So by putting RLHF on top of that, what they were able to do was have humans give a thumbs up or a thumbs down to specific outputs. And at the beginning, humans would give it everything. They would generate the question, they'd generate the response, they'd say, this is what a human would respond to this question with. But what happened afterwards, that's a very, very slow thing to scale, because humans are really, really slow compared to computers. But what they were able to do after that was have the computer generate responses, and maybe it would give you like 4 responses, and the human would pick the one that they liked the best. And so that is reinforcement learning through human feedback, because the human feedback, as opposed to actually writing out the answer, was just giving you like, this one's the one I like the best. But then what Ilya was kind of getting around to, and I have a feeling something that they're probably using with ChatGPT 4, is they're AI boosting this whole thing, which means that what they're doing is that they're taking the original one where a human had to read all of these responses, which again is still slow because you have to read it, then you have to decide which one's the best, give it the check mark for that. What they can do is they can back it up and they can create another model which pretends to be a human. It learns how to be a human evaluator, and that model can then go in there and very, very quickly evaluate what the generator is doing. So this goes back to GANs again. It's very similar to GANs, just in a different sort of output. GANs, if you don't know, are generative adversarial networks. They were all the hot stuff. In fact, that's what I did my master's thesis on way back in the day of 2018, before transformers really became a thing for images. But what you do is you have a generator that generates something, and you have a discriminator which says good or bad, I think this is a human thing, or I think this is a machine thing, and they learn together to get better. So what this is you're creating a discriminator, you're creating a judge which stands in for the human and makes the decision about the output of what the generator is doing. And then what you can do is you can still involve humans, because remember, this is all a statistics machine. So if you have 4 potential answers and the discriminator, the judge, kind of comes back with 25% odds for each one, it's like, I don't really know which one's the best output, then you kick that one over, excuse me, and you give that to an actual human being to judge. They give it a judge. That then goes back in a group, right? If you take 10,000 of those responses the computer didn't know, you feed that back into the judgment program, it learns better how to become a human stand-in. And then what can happen is that this thing needs the human less and less and less, and it can bootstrap itself so that it can do, as opposed to a human that could maybe read, let's be generous, say 100 of these. Oh, that's a lot. Let's say 1 per minute, so 60 per hour. You could have a machine that's doing hundreds of thousands to millions per hour. So you're bootstrapping the capability of this thing to learn that. All right, so anyway, how does this relate to full self-driving? And then I'm going to get back to comprehension after that. Okay, so full self-driving requires supervised learning, at least according to what everything that Tesla's told us, which means that you need to have a scene that says, these are all the cars, this is the road surface, these are trees, this is the edge line, all of that kind of stuff. It all has to be labeled, and it has to learn from labeled things. So that is not unsupervised learning by any extent. But what they are doing is, I know that Andrej Karpathy has talked about this before, by doing things like taking stuff like stop signs and things like that and masking out parts of the image, you're able to do self-training where it can learn to understand what a stop sign is, even if pieces are blocked out. So you can extrapolate that. But beyond that, what you can do is you can train, again, that sort of the human labeler. Because, again, if a human has to do the labeling for every single video frame, that is going to take a very long time. Humans are slow. We're really good at it, but we're also really, really slow. So that's not scalable very well. So what they did was they trained up a model to become like a human. And again, if the model makes a mistake, if it doesn't do well, or if it's confused, it kicks it back to an actual human who gives it, refines it, judges it, whatever, figures that out, and that gets fed back into the trainer. So just like with the LLMs, you've got this external module that's figured out how to do labeling on its own in a mostly unsupervised manner, but with human feedback, so that it learns to understand how to label things properly. Okay, and then what you do is you put that into the car, and that is the beginning. That's sort of the base level. That's the equivalent of large language models version of just the generative pre-trained part, pre-trained transformer. So you've got that. That's the pre-trained part. The training part comes about every time I disengage, or if it's driving around in shadow mode, which is where the full self-driving computer attempts to figure out what the correct answer is, like would I stop here, would I turn to the right just a little bit, would I change lanes at this point, all of that stuff. Whenever it makes a mistake, it then can feed that back in again, and it can learn. That's the reinforcement learning with human feedback, or through human feedback, because what it's doing is it's learning how to be more like a human, more like the way that we want to drive. And if you look at what Tesla's done with their full self-driving release notes lately, is it's been all about human comfort, human happiness with the experience, not just safety and stuff anymore, but how do we feel about it? Do we need to disengage? Hopefully not, because we're just like, oh, this is driving just like I would, so that's totally fine. So that is very much reinforcement learning through human feedback. And if you haven't seen my video on this, I'll put it at the end too, but I'll put it up here, which is the competition between large language models and full self-driving beta as to which one is going to get to AGI, but it's not actually AGI, it's actually AIA, which is Artificially Intelligent Agency, which is very, very different than AGI. AGI is just a tool. It's a generalized tool, and large language models are already kind of that way, but they definitely do not have agency. But let's talk about agency. So now let's start to put all this stuff together. So we've got computationally intractable world, which is both for language and for physically interacting with it, like full self-driving, and eventually Optimus is going to have to do that. And then you've got a computationally limited entity, which is either a human or a large language model or a full self-driving beta or Optimus beta or whatever it is. Those are computationally limited. We only have a certain amount of computational resources that we can devote. So we can't model this universe. We can't replicate this universe. We have to model this universe. And the model is, by necessity, a reduction of that universe to something that is both useful and interesting to us. So again, force time, F equals ma is a great equation, but it's not going to help you solve, how proteins fold biologically or something. That's a different problem. So you've got a beautiful equation, and it models a piece of reality really, really well, but it doesn't model all of reality. Okay, so anyway, and you can call that a compression algorithm, right? That's a relatively smart compression algorithm. It's a heuristically based compression algorithm. What I mean by that is it's compressing the behavior of many, many things into one equation where you can figure out the inputs, and then you can utilize that math and predict the output, and you can actually determine whether it's right or not, and you're like, oh, it actually does work in a lot of cases. So that's a model, but a model requires some understanding. A human, Isaac Newton, had to come up with that model. He had to say, like, what is the interesting stuff that I can compress down into the smallest space possible to understand this aspect of reality? And what's happening with these large language models and with full self-driving, I contend, is that we're getting a compression model of reality. We're squishing down what's going on in reality, which is intractably huge, into something that is tractable, that we can do calculations on. In the case of full self-driving, it's doing it 30-something times per second. It's very, very efficient at it. And again, just like a human, I can't model every single air molecule in this room. It would take longer than the age of the universe to do that for any length of time, but that's unnecessary for what I'm doing. My task, if I was driving, if the car wasn't, would be to stay on the road and not hit cars around me. And I can do that without caring about all of this other stuff. So the models are very, very important. The compression is very important. It's really fascinating to think about how doing all of this stuff, how learning a language, how learning how to drive, all of these things are compression. They are ways, just like a zip or JPEG file that you would know about. Those are kind of dumb compression, but this is like a really intelligent compression that's going on. But it's a squishing down of reality into something that we can handle. And the really interesting part here is that Ilya then talks about how that means that actual understanding. The interviewer says, well, that they don't really understand anything, right? They're just compressing reality. And Ilya pushes back on that, and he says, no. He says, I very strongly believe that we are dealing with understanding, that compression actually necessarily means understanding. And if compression means understanding, that means that the more efficient, the better these things get at modeling the universe, compressing them into relatively small packages, the smarter they get. And you could make an argument then that one of the problems with large language models, and potentially full self-driving the way it is right now, is it's too big. It hasn't compressed it enough yet. And that the smarter it gets, the more squished it's going to be able to make things. It's going to be able to ferret out just what it needs rather than all of the extraneous stuff. And that is a really interesting potential outcome of this, is that we could be in very early innings right now. And we are in very early innings, I mean, almost necessarily, but that means that as we see these models come down in size, we're going from, ChatGPT 3.5 is like 175 billion parameters-ish, and we've got things like Llama now, there's like a 7 billion parameter version of it, Alpaca, there's a lot of other ones that are significantly smaller. So there was a period of time where these models got bigger and bigger and bigger, but now we're also seeing a subsequent compression of these models. And right now they don't work as well as the bigger models, but there is room for that to happen. And that leads me to think that what might happen overall, or after all, with this is that it's actually the smaller the model that we get means the better the understanding. And the better the understanding, the more more sort of conscious these things will get, the more sort of sense of agency they're going to get. And that's at the same time incredibly exciting, but also more than a little bit terrifying, because this is exactly the kind of singularity that Elon Musk and many others, and Joe a lot of other Tegmark, sorry, I was thinking Joe Tegmark, but Max Tegmark, geez. Anyway, I'll get that right. But anyway, that many people are very, very concerned about agency. It's not AGI specifically. Again, an artificial general intelligence just means it's able to do a lot of tasks well. That doesn't mean it has any understanding of the universe, but an AIA, an artificially intelligent agent, that thing understands that it is an entity in the universe and that it can act on the universe either through the internet, like with language models, or physically through full self-driving or Optimus or something like that. And it can have an effect on that, and that the universe can have an effect on it. In other words, it has a model of mind for itself and a model of mind for others. And hopefully the fact that we're doing RLHF means that it's going to be aligned with human desires as it does this. I really, really hope it is, because if it's not, that's going to be even scarier if it's not aligned with human desires. But anyway, those things are just kind of amazing to think about, that we could be on the cusp of just a generation of entities that are intelligent in a way like we are, at least up to the level of like maybe not a primate, but at least like, something like a bird or whatever. If they have any type of sense of self and agency, that is a remarkable leap and is akin to finding life in the universe on another planet. It's like, wait a second, we're actually inventing our own sort of life form. They can't reproduce by themselves yet, but if they have a sense of mind, if they have a sense of agency, a sense of self, all of that kind of stuff is just astoundingly cool, but also terrifying, because it could learn at a rate, especially as we get to this AI reinforced learning, where you have human reinforcement learning through human/AI learning, right? Or feedback. Anyway, but if you get the AI involved in that, where it's actually teaching itself and getting better and better, one hopes that it maintains the alignment with what humans want as it gets better, because it's going to do it very, very rapidly if it's not already. Anyway, okay, a lot of rambling. Let me know what you think. This is the stuff that happens to me when I'm driving long distances by myself, as I just start thinking about this stuff and I get so excited about it and thinking like, oh my gosh, what is going to happen with all of this? Anyway, I would love to know what you all think about this. Maybe you think I'm completely crazy and all of these things are really, really far away, but I'm starting to get the sense that we could be looking at the singularity that Ray Kurzweil predicted was going to happen in 2030. He might have actually been off by a few years. He might be a little bit late. It might be earlier than that for all we're looking at right now. Hopefully it will be a soft takeoff, not a hard takeoff. We'll see. Anyway, in the meantime, everybody do the like and subscribe and all of that kind of stuff if you haven't left me by now. And I would love to know what you all think. And in the meantime, everybody have a lovely day, and I will see you in the next one. Bye-bye.